Okay, so here's number 5 from the practice problems. 2 NASA satellites, Discover and Explorer, are sent to orbit Mars. Discover is in a low planet orbit just above the surface, and it takes 1.67 hours to complete one orbit. Explorer takes 5.1 hours to orbit. The radius of Explorer is 2.1 times the radius of Discover, and the mass of Mars is 6.39 times 10 to the 21st kilograms. Both satellites have the same mass. If Discover, which is in the low orbit, experiences a force of gravity of 2,800 newtons due to Mars, what is the force of gravity felt by Explorer? So you've got Mars. I'll use red since it's the red planet. And then you've got the 2 satellites orbiting Mars. The one is right at the surface, and then the other one is 2.1 times around. So you've got the Discover right at the orbit, and you've got the Explorer, right above the surface, and then you've got the Explorer 2.1 times away from where Discover is. So for our given information, we know that the period for Discover, I'm just going to call that TD, is equal to 1.67 hours. We know that the period for Explorer, I'll call that TE, is 5.1 hours. The radius for Explorer, call that RE, is equal to 2.1 times the radius for Discover. Doesn't matter if you use capital or lowercase r. Let's make that lower for consistency. The mass of Mars, call that MM, is equal to 6.39 times 10 to the 21st kilograms. And the force of gravity for the Discover, I'll call that FGD, is 2,800 newtons. And we know that the mass of the Discover is equal to the mass of the Explorer. Given all of that information, we are looking for the force of gravity felt by the Explorer. Okay, so let's start with what we know. We're dealing with gravitational attraction, so that is the only force acting on either of these satellites. So Fg for the Discover equals our gravitational constant, mass of the Discover, mass of Mars, over the radius of the Discover squared. And we know that the force of gravitational attraction for the Explorer equals G, mass of the Explorer, mass of Mars, over the radius of the Explorer squared. These are not equal to each other, again, because they have, even though they have the same mass, they have different radii, so the force of gravity can't be the same. We know that the Discover is closer than the Explorer, so this is going to be larger. We don't know what the radius of the Discover is. We don't know what the mass is. We do know the mass of Mars, we know G, and we do know this. So what we're going to do, because I know that this mass is equal to this mass, is make a substitution. So isolating this mass right here, again, because MD equals ME, I'll be able to get rid of those and then set these equations equal to each other, looking in the end for FG. So let's get started. FG for the Discover times the radius of the Discover squared equals G MD MM. Divide both sides by GMM. We get FG for the Discover, radius of the Discover squared, over G, mass of the moon, equaling mass of the Discover. And on the other side, this is going to turn out to be the same thing since we're dealing with the same equations. So FG for the Explorer times the radius of the Explorer squared over G times the mass of Mars equals the mass of the Explorer. Because MD equals ME, we can set this equal to this. So we get Fg for the Discover times the radius of the Discover squared over g times the mass of Mars equals Fg for the Explorer, radius of the Explorer squared, divided by g times mass of Mars. These appear on both sides of the equation, so we're left with Fg for the Discover times the radius of the Discover squared equaling Fg for the Explorer times the radius of the Explorer squared. Looking for Fg of the Explorer, isolating that, we get Fgd Rd squared over Re squared equaling Fge. Our given information told us that the radius of the Explorer was 2.1 times the radius of the Discover. So Fgd times the radius of the Discover squared over 2.1 times the radius of the Discover squared equals Fge. So Fgd, radius of the Discover squared, over 2.1 squared, which is 4.41. Rd, that's a 1, not an R. 4.41 Rd squared equals Fge. You don't even need the radius of the Discover, so we're left with the force of gravity for the Discover, 2,800 newtons, divided by 4.41 equals Fge. Dividing those two numbers, we get 634.9, keeps on going, newtons, for Fge, 2 sig figs. The force of gravity felt by the Explorer is approximately equal to 630 newtons. This is less than the 2,800 newtons for the Discover, as it should be, because it's farther away. So because it's 2.1 times as far away, you just square the 2.1, divide that by 2,800. That's what we ended up with in the end. I went through all the steps to show what you would do in the case of not being given as much information, but this is how we figured it out. So the simpler way to do this is knowing that the force of gravity is proportional to 1 over the distance squared, so 1 over that radius squared. Since the mass is equal, it has the same g, and you're dealing with the same planet, you could have also looked at this as 2,800 newtons is proportional to 1 over the radius. So again, it was 2.1 times the radius of the Discover squared. So 2,800 newtons proportional to 1 over 4.41. So that means that your force of gravity for the Explorer right here would have to be 4.41 times less than the force of gravity for the Discover. So again, this is the oversimplified version. It still works of how to do this. I took all of these steps to show you how things would cancel in the case of not being given as much as we were.